Just a break.
All right, we're on page 138. Composite functions. All right, now composite functions, they're not difficult at all. It's kind of difficult to explain at first, but once you figure out what I'm doing, it's really easy, but you got to listen to what I'm telling you is going on. You don't want to be sneaking a Snapchat, okay, during my lesson. You want to be paying attention. All right. So when the output which output is your range, of course, or your y values, we know that. From the first function, bless you, becomes the input which is your domain or your x values of the second function. That's what a composite function is. Basically, you have two functions, one inside the other. You evaluate the innermost function first. It'll give you a number for x. You evaluate that first. Take that out. That'll be your output because your input's your x value. You simplify. The result is your range, which is your y value, right? That result will then be your input or your x value for the second function. That's what we do when we compose functions.
What do you mean a function inside a function?
A function inside of a function. It's crazy. You'll see it in a minute.
Yeah.
All right, the composition of function g with function f is written as, that says is, goodness, G, there's a little circle, make sure that does not look like a multiplication dot, it's a circle like of, G of f of x. Or you may see it as G of f of x. You say it the same way both times. I don't like it with a little circle. To me, it makes more sense to write it like this, but you could see it given to you either way, okay? So in this example, whatever they give you for your input, your x value, you would evaluate function f first since it's the innermost function. Whatever that result is, your output, then you plug that in to your function g. Okay? So we're going to evaluate the innermost function first. In this example, it's f of x, but it doesn't have to be f of x. It's whatever the inside function is. Then use that expression to evaluate the outside function. In this case, that would be function g, or we would say g of x. But it's not always going to be a function g, just whatever's on the outside. Okay. So, for example, I'm going to give you two functions, function f and function g. We're going to let f of x equal x minus 5 and g of x equal x squared. I haven't given you a question yet. I'm just telling you what function f and function g are, okay? So my question is, what is g of f of negative 3? So this is how it may be given to you. Me personally, I don't like it written like that, so I always rewrite it. You don't have to do that. I always rewrite it to look like this. G of f of negative 3. To me, that just makes more sense. So since function f is my innermost function, it's saying, in function f, evaluate your domain at negative 3. So basically, I'm plugging in a negative 3 wherever I see an x in function f. They could have told me to do f of g of negative 3, then I would do g first, okay? So whatever's inside. So I'm going to take function f, and I'm going to evaluate it when my input, my x value, my domain, is a negative 3. So I'm going to evaluate f of negative 3. And I get negative 8. So I evaluated my first function, but that's not my answer, okay? I just evaluate that first. And then now that's going to become my input, or my domain, or my x value of the outermost function, of function g, okay? So I just take function g, and I'll evaluate it when x is negative 8. And parentheses are going to be important there. Whatever x is, I square it. Since x is a negative number, I have to make sure and square the negative as well. In your calculator, if you don't put parentheses, it might tell you the answer is negative 64, but is that correct? No. Our answer is what?
64.
Positive 64. Did I say if it tells you it's negative 64? Oh, okay. That's what I meant. And that's it. That's the answer. You evaluate your inside function, the result, plug it into your outside function, boom. I know. It's harder to explain it than it is to actually do it.
Is it saying this easy?
Hmm?
Is it saying this easy?
Pretty much. I mean, it just depends on the function. They could get a little more complicated, but
Define a little.
not barely. Barely. Anybody still writing or have a question?
It's just getting more work, isn't it? Not very much, not very hard, but just more work.
Yeah.
So this is like busy work.
No. No. You'll see this on the FSA. If it's on the FSA, it's not busy work because we got to know how to do it. So we need some 3s, 4s, and 5s.
It's funny because we do like 12 problems about the same thing, but only have to say it one time. Yeah.
Well, I mean, the FSA is 60 questions over an entire year of work, so they're not going to keep repeating the same.
It's only 60 questions.
30 the first day, 30 the second day.
I always repeat.
All right, page 139. All right, I'm changing my functions. In this example, I'm going to let g of x equal 2x. And h of x equal x squared plus 4. And my question says, find h of g of 1. That's not hog. It's h of g of 1. Nope. Of course, I'm going to rewrite it. Just my preference. You don't have to do that. To me, when I write it like that, it just is more logical that you're evaluating function g first. You know what I mean? So, what function am I starting with? G, like I just said, right? So function g is g of x equals 2x. And what's going to be my input or my domain? 1, whatever the question tells me. So I'm going to evaluate function g when x equals 1. That was pretty tough, wasn't it? And then do I stop there? No, what do I do now? I'm gonna, yeah. So now 2 is going to become my input for function h. So I'll evaluate function h when x equals 2. And just simplify. That's it. Coolio? Let me give you 2 new functions. Am I going too fast?
No.
Sure?
No.
Well, last class said I was moving at the speed of light. And I was going about this fast. Alright, let f of x equal x squared and g of x equal x minus 3. I'm going to do 3 separate problems here. So I'm going to separate the bottom of my page into like thirds, okay? My first example, I'm going to find g of f of negative 2. Y'all ready to try it on your own? I'm going to pause, try it on our own, okay? Those of you watching at home, pause the video, try this on your own. Okay, so we evaluated function f first at negative 2. And we got, if our input was negative 2, our output was 4. So 4 will become the input of function g, our outermost function. So I plugged in a 4 for x, and then 4 minus 3 is 1. Everybody cool with that? Anybody have questions? Okay, now this next one is a little bit different. We are going to find f of g of a.
Ooh.
Well, yeah, but the x will go away because I'm going to turn the x into an a. I'll do this one with you. Although I have no doubt that you could all do it on your own. So I'm going to rewrite it. F of g of a. So what function am I using first? Function g. And what will I be substituting in for x? A. So I'm finding g of a. Wherever I see an x, I'll plug in an a. Can I do a minus 3?
No.
No. In this case, my input was a, my output was a minus 3. No big deal. So when I go to function f, my input will just be a minus 3. And then I'll just do whatever the problem says to do, right? Y'all good with that?
Yeah.
So function f is x squared. So it's saying whatever your input is, you got to square it. Are parentheses going to be important? Yes. So do I just do a squared and 3 squared? You better not. What would I do? You've got to FOIL it. Yes. So that would be a minus 3 2 times. Not a squared and 3 squared. Please don't do that. And then we could do this in our sleep, right? First term times first term is a squared. Outer term times outer term is minus 3a. Inner term times inner term is a minus 3a. And last term times last term is plus 9.
9.
Negative 3 times negative 3 is positive 9. And then when we combine our middle terms, we'll get a squared minus 6a plus 9. We ended up with a quadratic. Is that okay?
Now use the quadratic formula.
Nope. We're just composing two functions.
No.
Plug in one function inside the other, that's all. No quadratic formula. We're not solving for x. So when you said, is that as hard as it gets? This is probably as hard as what's going to get with us. Okay? Last one, and then an assignment you can practice on your own. And you can do this one on your own. G of f of 0. And I will pause, take a short break while you all figure this one out.
Hi guys.
Okay, so we got a negative 3 here. We did function f first. We plug in a 0 for x. And when we did that, we got an output of 0. That's become our input of function g. Plug in a 0 for x, and we get negative 3. And that's that. Now, on the assignment that I'm going to give you in your workbook, is everybody finished with this before? Because I'm going to show it up, cover it up. Anybody have any questions? Okay. It's going to be on 175, and I'll tell you the problem numbers in a minute.
Okay, I turned in that paper.
But the directions give you, I think, 4 different functions. Function f, function g, function h, and function j. They just did that so for each question they didn't have to change the function up every time, because you can only ask what g of x is or f of x is, right? So they gave you 4, and then each question, it's only going to use 2 at a time, though. You know what I mean? So you're not going to use all 4 functions in every problem. It's just giving you 4 different ones to start with. Does that make sense? Okay.